f minus g of x is defined to be f of x minus g of x. And so f of x in this case is x minus 5 minus g of x is x squared minus 1. So here the parentheses are a little more necessary than they were back with the addition. Now, I don't need this first set, but I do need to include them around the second set because we want to make sure we're subtracting off the entire function g of x. That means I'm going to have to distribute that negative in order to get rid of those parentheses. And if I don't have the parentheses there and I just leave a minus x squared minus 1, then I'm not actually subtracting all of g of x. I'm only subtracting that first part of it. So you need to be careful with that, especially with our subtraction. So to remove the parentheses, I need to distribute that negative into that second set. Now we can go ahead and look for like terms, so I'll rearrange things again, and that's negative x squared plus x. And then we have minus 5 plus 1, so that's a minus 4. And so there's our function f minus g of x. And so we're also being asked for the domain, and the domain is dependent on the domains of f and g. And so we look at the domains of f and g separately. So the domain of f, when I look at that function f of x equals x minus 5, I don't have any of those typical types of things that are going to restrict the domain. Those would be square roots or variables and denominators. So we don't have either of those there. So our domain's actually going to be all real numbers, negative infinity to infinity. Essentially we can plug in whatever number we want for x there, and we would get a number answer. And the same thing in the function g of x. We don't have any square roots, we don't have any variables and denominators. We can plug in any number we want into that function for x. So our domain's all real numbers. Generally the domain of f minus g is going to be where the domains of f and g overlap. So in this case that's going to be all real numbers. And the domains of f plus g, f minus g, and f times g are all going to be the same for the same two functions f and g. So that's where the domains of f and g overlap.